Hello everybody, this particular presentation is on the one-to-one functions, and you'll find a few of those in 1C. Now I'm hoping you'll remember a few of the things from Math Methods last year. Now if we want to do, what we want to do is to define the maximal domain if f of x is equal to x squared plus 2x plus 5 is to be a one-to-one function. Alrighty, well let's have a look at this and see what we can figure out. So if we said f of x is equal to x squared, now what I'll do is I'll complete the square. So look at the number in front of the x, that's 2x. Half that 2 is 1, 1 squared is 1. So I'll complete the square, putting in a plus 1 and then a minus 1. Now, these three become a perfect square. So this will be x plus 1, and minus 1 plus 5 is plus 4. So my turning point will be at minus 1, 4. And if you'd like to just check, you can figure out the x or the y-intercept by making x equals 0. So that would mean if we put in x equals 0, 0 squared plus 2 times 0 plus 5, the x-intercept would be at 5. So that would mean that if we sketch this, here's negative 1, 4 across there. There's 0, 5 there. Now our graph will turn around at the turning point at negative 1, 4. Now, there are two parts here, I guess. If it's to be a one-to-one function, it must pass the horizontal line test. So I'm hoping you remember that, the horizontal line test. So for the horizontal line test, a horizontal line is only allowed to hit one point on this parabola. Now at the moment, it hits 2 points, so it's not a one-to-one function. What we can do is restrict the domain so that it is a one-to-one function. Now what about if I chop this in half? So I had a half like that and a half like that. So I could say the domain of the yellow one would be from negative infinity up to negative 1. Or, for the domain of the red part, I could say the domain would be from negative 1 up to infinity. Okay, so either the yellow part or the red part would be correct. Both of those provide a maximal domain for this particular parabola. Alrighty, let's try one more. Okay. We want to find the minimum value of a. Now here's the domain defined in my function here. We want to find the lowest possible value of a if this function is to be, if this function is a one-to-one function. Alright, so what is this going to look like? What is this graph here going to look like? Well, if you hadn't already guessed, it is actually a truncus. So if I said f of x is equal to x squared minus 4x plus 4. This quadratic trinomial on the bottom can be factorised to be 1 over x minus 2 all squared. It's a perfect square. Now that is a truncus. Now the minus 2 means it's shifted 2 across to the right here. And my truncus will go like this and like this. So now we want the part of this from negative infinity up to a maximum value. I probably should have had a round bracket there. So the domain should be from negative 2 up to 2. Okay, so the maximum value a could be is 2. Any lower than that, well, it's not the maximum value, and any higher than that, say a was on the other side here at 3, this wouldn't be a one-to-one function because a horizontal line would hit the graph in 2 spots, meaning it isn't a one-to-one function. Alrighty, well I hope that helps. I'll see you in class.